every number is unique. But there are infinitely many numbers. How can every number be unique? Well, it's all because of prime numbers. Every natural number has a prime factorization. 302 can be expressed as the product of the two prime numbers 2 and 151, and 550, for example, can be expressed as the product of 2 times 5 times 5 times 11. But how many prime factorizations can a number actually have? We start with the natural numbers and assume that there is a subset of numbers which can have more than one prime factorization. So we have numbers with at least 2 prime factorizations. For our investigation, we will pick out the smallest number in this set, in our case the number n. N is the smallest natural number with at least 2 prime factorizations. This means that every natural number smaller than n has only 1 prime factorization. So let's take a look at the 2 prime factorizations of n. So n can have the prime factorization of p1 times p2 times so on times pr, but also it can have the prime factorization of q1 times q2 times so on times qm. So what we are seeing here is that the product of p1 times p2 and so on should equal the product of q1 times q2 and so on until qm. But we don't know what the relation between those prime numbers is. We don't know if p1 equals q1 and p2 equals q2. So we have to find out what the relation between those prime numbers is, and we start by taking a look at the prime number p1. So, since p1 is a prime factor of n, we can conclude that it divides n. N, on the other hand, can be expressed as the product of the q prime numbers. And this means that p1 also divides this product of q1 times q2 and so on times qm. But according to Euclid's lemma, we can conclude that p1 has to equal at least one of the q prime numbers, which we say is q1, so p1 is equal to q1. So our product has changed. On both sides of the product we have a p1 which can be dropped now, so we're left with the product of p2 times p3 and so on up to pr, and this is equal to q2 times q3 and so on until qm. We can define those products as new numbers. The p product will be the number a, the q product will be the number b. Both numbers are smaller than n. And this means that both a and b have a unique prime factorization, because n is the smallest number with at least 2 prime factorizations. So together with Euclid's lemma, we can conclude that all the prime factors are equal. This actually means that there cannot exist a smallest number with more than 2 prime factorizations. And this again means that every number has a unique composition of prime numbers. Just like each element in the periodic system has a unique composition of protons and neutrons that make up the properties of the element. So there is infinity of special numbers, and this is why every number is unique.